Okay, greetings all. Welcome. Today we will talk about your favorite subject, of course. We will talk about the game of life. So this is to get you ready, just a prep. So let's just jump right in. Whoops, there we go. Okay, so we'll begin with a little review, go over the rules, no big surprises here, but just to make sure we're all on the same page, we'll begin with a review. I'll show you a strategy for iterating through the 2D world that is the game of life, and applying the rules. I'll show you some pseudocode. I'll also show you a code skeleton. I want to caution you. I'll share this, these snippets of code with you. Take what I show you and incorporate it into your own ideas. Do I want you to do your own work? Of course, but I've got another motivation, another caution. The code I show you, and you can use the ideas and the things that I show you freely at your own discretion. Just don't get too locked into it. If you have ideas of your own, go ahead and use them. If what I show you doesn't work for you, do what works for you. So we'll jump right in. I've also got, in order to do this, you need to have some facility. You're going to do a fair amount of manipulation of 2D arrays. And I've got a little review on 2D arrays for you. So let's jump right in and go over the rules. Okay, no surprises here. The game of life rules, it's played on a grid of cells. A cell is said to be alive or dead. It is a two-dimensional grid. Rows and columns. Boom, boom, boom. The rules, once you've seen them a couple times, they're pretty straightforward. There's the birth rule. A dead cell with exactly 3 live neighbors becomes a live cell. So let's just take a second. So here you see this highlighting in yellow. This cell here will apply the birth rule to this cell. Note that there are 3 neighbors, 1, 2, 3. Remember, the diagonals count as well as the cells that are immediately adjacent. Here, sort of the same thing, just a little bit different configuration. Here, this cell also has 3 live neighbors, so the birth rule will be applied. Remember, it's 3, not 4, not 5. Exactly 3 live neighbors. The survival rule, a live cell with 2 or 3 neighbors stays alive. So here are some steady state cases. The live cell just stays alive. And last, there's the overcrowding / loneliness rule. So a cell dies or remains dead in the presence of overcrowding, too many neighbors, or loneliness, not enough neighbors. So this is sort of the default rule. Here we see the first case. This cell will die in the next generation because it only has 1 neighbor. So this is the loneliness rule. Conversely, here is the overcrowding rule. This rule, this cell will die in the next generation because of overcrowding. Okay, so those are the rules. Here's just some general notes, some general observations. So the number of live neighbors is based on the state of the game, or the state of the cell, before the rules are applied. This is simple, but it's very important that you understand it. When you're working through your grid, a cell at a time, you'll go ahead. What will you do? You'll count the neighbors, and you'll apply the rules based on the number of neighbors, and you'll make the determination of what's going to happen to that cell in the next generation. So is it going to be is it going to apply the birth rule? If it's already alive, do you have a steady state case? Or is it overcrowding or loneliness? So what you need to do in this case, record that information in another 2D array, and you can call it next generation. That's what I always call it. I call it next generation. You can record that information in another 2D array. So you're working through it, and you're setting the state of each cell in another 2D array. The idea being you don't want to disturb the state of the array or the generation or population, if you will, that you're working in. So just it's simple, conceptually pretty simple, but just make sure you understand that. And that's why you should have two 2D arrays. The game must be initialized with a population. So you can use a random population or known patterns. We've talked about the glider a fair amount. It's a nice simple pattern with a known behavior, a good one to start with. The game is played in generations, so a new population is created each generation based on the current population, and we go dormant or we sleep between each generation. And depending on the length of this sleep, you can create some pretty interesting visual effects. So, and to cause your process to cause your thread, if you will, to sleep is pretty easy, and sleep just means you go into a dormant state. There's no computations being performed. You can just use this static method of the thread class. Thread, and here the example thread.sleep 300. The argument is a number in milliseconds. So this will cause your thread to go dormant for 300 milliseconds. You shouldn't use a number like this, a literal number like this. Use this as a parameter that's set via the UI and propagated in. Give the user the ability to vary this sleep time between generations. Here's some references for you. This processes in threads. That's from the Java tutorial. And you don't need to be an expert on threads. Use some of the Android tools for handling threads. And here is your game of life reference. I'll open this a little bit later, but this is the one from math.com, which I think is very useful, very comprehensive, great information there. So those are the rules, and here are some general observations. We'll look at a strategy in our very next video. See you there.